Now, very quickly, I need to make we all remember what a monomial is, do we? No. A monomial is anything that is a single number, a variable, or an exponent, all connected by multiplication. So, 3, that's a monomial. 3x, that's a monomial, because they're connected by multiplication. 3x squared, still a monomial, because it's all multiplying. 3x squared y, still a monomial, because it's all multiplying. 3x squared y cubed z, still a monomial, because it's all multiplying. Everybody good? Yeah? Okay. Now, being the intelligent young people that you are, bring previous math knowledge to the party. Dividing is the inverse operation of what? To multiplying. Excellent. Now, when you add, what is its inverse? Subtraction. And we do the same thing, right? If I add 6 and 2, I have 6 things. Shoot. If I add 5 and 2, I have 5 things. I add 2 more things, and I get 7 things. Yes? Reverse them. I have 5 things. I take away 2. That is the same as adding negative 2. Here is negative 2, because I'm using the other fingers. They cancel those ones out. The ring finger and the pinky disappear, and I'm left with 3. Everybody understands inverse operations, yes? Excellent. And you do the same thing. So it is the same thing with dividing as it is multiplying. 5 root 2 times 3 root 7 is what? This is what we did like yesterday. Oh, did I show you all the answers? I didn't? Okay. Hold up a moment. You have not seen all these answers? Oh, you'd better check and make sure then. This was page 43, I think, because we did up to number 2 in class. 42. I believe I assigned 43 as homework. So check your work first, because it's hard to go on to dividing. If we are bad at multiplying. Oh, I remember. I said I was going to put all this up as the key. And it's on the video. So you should have watched it. So we can go on. Excellent. So to remind you, what is this? It is... How do I... No, that's multiplication. How do I do that? It is 5 times 3 root 2 times 7, yes? The coefficients multiply together, the radicands multiply together. What is the rule that must be observed when we actually have numbers under there? What do we have to have the same so we can actually multiply? The index, right? If it's a variable under there, it's okay because we can make it an exponent, yes? But in this case, we are stuck. They have to be the same. So, we remember the coefficients go with the coefficients to give us that, and the radicands go with the radicands to give us that, right? Logically then, what would 15 root 14 divided by 5 root 2 be? 3 root 7. Because that times that got me that. So if I reverse it, I get the same thing, yes? So without me even teaching you, you all should be able to come up with the rule for what we do here. Right. That becomes 15 divided by 5 and root 14 divided by root 2, which would be 3 root 7. Yes? Without me even teaching, you can figure it out. It's easy peasy lemon squeezy, right? And does all the other math rule apply? Every math rule we've ever been taught, ever in our lives, from kindergarten, even if you were in ESL, all still apply, don't they? We don't get to say, I don't like that math rule, I don't need it. No, we keep it all, yes? Okay. Now, there is one small rule, and I'm going to put a star there. Denominators cannot be irrational. So let's start working on this. This first one here is pretty easy, right? Why? What makes that one particularly easy? They both divide, don't they? 9 over 3 equals what? 3. And 18 over 6 equals what? So my answer in purple, which mixes blue and red, must be 3 root 3. Yeah? Easy peasy lemon squeezy, right? Okay. Is there anything different about B? It is written differently, but is it the same? If I were to rewrite B in a more pleasing to the eye version of it, it would be 15 root 15 x cubed y squared over the root of 3xy squared, yes? Okay, so the first part of it would be 15 divided by what? 1, which would get me 15. And the second part of it would be 15x cubed y squared divided by 3xy squared, which is what for an answer? 5x squared, right? Everyone agrees? Okay, so we would put them together using purple, because red and blue makes purple, to get 15 root 5x squared, yes? Would you stop there? Some of you will stop there. Would that get you the 3 in meeting my expectations the way I have to do it? Because it's stupid, because to meet my expectations, you should go all the way through the question. But if you were to stop there, would you get the 3? Yes. Do you want the 4? We have had that discussion a few times. Do you want the 4? So what do you have to do? You got to take that x out of there to get 15x root 5. Now, could you take that x out at the beginning? Of course you could. You could make this at the very beginning 15x root 15xy over xy squared, over root 3xy squared. And then those would just cancel out right away. It doesn't matter where you simplify, as long as you simplify. Yeah, yeah? Yeah, yeah. Now, what happens in C? Nothing divides, right? So now, this rule comes into effect. Denominators cannot be irrational. You are never allowed to have a radical sign in the denominator that you cannot get rid of. So let me ask you this. Would what I'm about to write be okay? Is that allowed? What I just wrote in red. Yes, why? Because this is 7, right? That's okay, because I can get rid of it, because it simplifies and the radical sign disappears. Everybody cool? Because the square root of 49 is 7, Bea. You know that, though. Right? Yes, because that is the answer. Because the root of 49 is 7, right? Now, would this be allowed to root 7? No, because 7 does not have a square root. Is everybody good? All right. So here we are. Now we're doing this thing because this isn't allowed. So if something's not allowed in math, we got to get rid of it. All right? And every time we need to get rid of something in math, what do? Don't write this down. Just let me remind you. If I gave you x plus 7 equaled 10, what there is no good to us? The x is what we want, right? The 7 is no good to us. So what do I do with it? I subtract 7, right? What if I gave you this? 7x equaled 35. What's of no use to us? So what do? Divide. So how do we get rid of stuff in math we don't like? We do the opposite operation, yes? Now when I say opposite, that's a little problematic because opposite in math really means positive or negative, yes? So the proper word is we do the inverse operation. So what is the inverse? What here in green is not allowed? The root 7. So how do I get rid of a square root? I square it, right? So if I want to get rid of that, I have to square it, which would mean I would have to multiply by root 7, wouldn't I? Is this a fraction? Yeah. If you do something to part of the fraction, what do you have to do to the other part? The same thing. Now, what is root 7 divided by root 7? This is not a trick question. 1. Does multiplying by 1 ever change a value? No. So is the answer here going to be the exact same value as the question? Yes, but it will look different. How will it look? Well, how do I multiply that? It's 2 root 6 times 7, yes? Over, how do I multiply that? 3 root 7 times 7, right? Which would get me 2 root 42 over, what's this bottom here? 7 times 7, which is 49. What's the square root of 49? 7. What's 7 times 3? 21. And there I'm done. Because this is allowed. You're allowed to have a radical in the numerator. The reason you can't have it in the denominator is it is impossible to divide by something that will never end. Does everybody understand? Okay. This number up top, regardless of how long it goes, we could continue to divide 21 into it, right? We just have to bring down the next number, bring down the next number, bring down the next number. And for the rest of it, eternity, we could do the root of 42 divided by 21. We just keep bringing down the next number and dividing and dividing and dividing. Everybody understand? Yeah. But this way is impossible. Because you can't divide by something that's never going to end. How would you cut it up? Everybody cool? All right, so let's look at D. Is D going to be doable? Yes. Not right now. We're going to have to do something special, yeah? Oh, by the way, I forgot to tell you what this is called. This process is called rationalizing the denominator. I'm going to highlight it in green to keep the green color going. So let's look at D. Are we going to need to rationalize the denominator? We are indeed. But is there something we can do first? I can simplify right here, can't I? Because what will 7 and 14 become? Half, right? And will we write 1 on the numerator, Bea? Of course not. We'd have root 5 over 2 root 6. What bothers us there? The root 6, because we can't divide by it. So we got to get rid of it. We got to rationalize the denominator. Now, do I need to put a 2 here? I don't need to put that 2 there because we're allowed to have a 2 under there, right? I don't need to put that 2 there. So I get the root of what in the numerator? 30 over what? Remember, my thinking here, and I'll draw a thinking cloud, is 2 times 1 root 6 times 6. Now, when you practice this a lot, of course you know root 6 times root 6 is 36, and the root of 36 is 6. So you know that root 6 times root 6 is 6. So this would be 2 times 1 times 6, right? So I'll keep my thinking bubble going. 2 times 1 times 6, which is 12. I'm sure you did. You seem very defensive about it, though. Now, that get any simpler? Where? Where? You understand this? Okay, well, what's 2 times 1? And what's 6 times 6? What's the square root of 36? 6. So you had a 2 out front and you brought out a 6. What's 2 times 6? Okay. Everybody good? Okay. What's weird about E? Is this going to work? No. Should I leave them like that? I'm allowed to leave them like that if I want. I could do this, but then my numbers will be big and my simplifying will be more difficult. So when should I simplify? Right now. What does this become? 6 root what? Oh, sorry. You should be able to do this in your head by now, ladies and gentlemen. 30 root 2. Why? Because that is 25 times 2. The square root of 25 is 5. 5 times 6 is 30. Over what? 15 root 2, correct? Now, some of you will say, oh, root 2, I got to rationalize it. Do you? No, because what's 30 divided by 15? 2. Root, what's 2 divided by 2? 1. What's the root of 1? Not a trick question. What's the root of 1? What's 2 times 1? 2. So there's our final answer. Because, of course, those will cancel. Is everybody good with the easy ones? Yeah? All right. Now, do any other math rules fall out of our head? No. Of course not. One of these is negative. So what is my answer going to be? Positive or negative? Negative. If this wasn't here, then what's the answer? Negative 2. And if this wasn't here, what's that answer? Maybe you can't do that in your head, so where do you go? What gives you math answers that you can't get in your head? Calculator. What's 51 divided by 17? 3. Are there any denominators that are radicals? No. So are we done? Yeah. Let's look at this one. What do I do with 4 and 8? Simplify to what, Jacqueline? Not 2. 1 over 2. 1 over 2. And what do I do with 5 and 10? Or 50 and 10? 50 and 10. What do I do? Divide. So it's root 5, right? Would I ever write that one? No. Do we have a denominator that's radical? No. So can we leave it? Yeah, we're done. Now, the next one, I don't know why it's an A, looks different. But you know how to do it. If this whole fraction has been square rooted, then what do you know about each part of it? They're both square rooted. So that is root 27 over root 10, yeah? What could we do now? Simplify. What does root 27 become? That's 9 and 3, right? So what's the answer? 3 root 3 over root 10. Do we have a radical in the denominator? Is it a radical that we can simplify? No. Are we allowed to have a radical in the denominator if we can't simplify it? No. So we got to get rid of root 10. How do I get rid of root 10? I multiply by root 10, but I have to remember to multiply them both by root 10 to get what for an answer? Three root 30 divided by 10. And we're done. Why? 30 doesn't simplify. Everybody good? Let me ask you this. What if I put a 2 there? What will happen to the rest of this? Where does that 2 live? Numerator or denominator? Numerator. So this 2 would still be here, wouldn't it? So this would be what? 6 root 30. Would we leave that? No. What's that? 3 root 30 over 5. I don't even know what bodily function that was. It was like a sneezerp. Or maybe, I don't know. I have no idea what sound that was. Is everyone good? It's pretty it makes sense, right? As soon as you hear that, as soon as you think about it, how could you cut up a pizza into... Huh? But if you order a pizza, it's divided into 8 slices, yes? Unless you order a small, then they only cut them in 6. But if you order a pizza, it's divided into 8 slices, right? And it's easy. Half, 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 half. Could you divide a pizza into root 2 slices? You couldn't divide a pizza by the square root of 2, right? It makes no sense. So all you got to remember is to get rid of radicals in the denominator. And you already know how to do that. You know that root 10 times root 10 is root 10 times 10. There's a pair, so out it would come, and you would get rid of the square root. Right? Yeah. Now, before we go on, I want to make sure of something. How would you get rid of this? Multiply it by what? So you would multiply it by cube root 3 over cube root 3. That's what you do? Okay. Well, that would be the cube root of 9, wouldn't it? What's the cube root of 9? Does not exist, does it? So, think about it. Your goal is to get rid of this cubed root, yes? So what does that mean you have to have under there? Thank you. If I want to get rid of a cube root, what has to live in the radicand? A group of what?
3.
A group of 3. So this would have to be 3 times 3 times 3, wouldn't it? So what does this have to be? Can it be the cube root of 3? What must it be? Cube root of 3 cubed, that would give me 4 3's under there. Squared. 1 3, 2 more 3's, 3 3's. Everybody good? Because we're multiplying and we can't forget our exponent laws, because that's math you learned in the past. What would this one be then? 4th root of 5. What do I multiply that by? Not the cube root of 4th root of 5 cubed. Answer.
So you actually want to write 3 underneath?
No, that's just to show you how to do it. What if I had 1 over x to the y? What do I multiply it by? This is tricky. Think about it. I'm going to have a sip of coffee because I feel I deserve it. What would I have to multiply here? Look at the previous examples and synthesize some information. You're intelligent young people. You do not need a fat old man at the front of the room telling you everything. You're smart. Look at what has already happened and figure out what this is going to be. Please notice that it has happened every single time. And if it happens once in math, it happens all the time. What am I writing here? I would have to write root y. What index would I have to have? X, so the index stays the same. And what's the exponent going to be? X minus 1. 4, 4, 4 minus 1. 3, 3, 3 minus 1. 2, 2, 2 minus 1. Okay? Right now by yourself, do C and D. Because you don't need me to do C and D. Something weird's going to happen with letter B, and we're going to talk about that as a group in a minute. Everybody do C and D. I don't know why the letters are all screwed up. They just are. Is everybody good with C and D? Yeah? Now, ladies and gentlemen, please do not do that teenager thing where if you simplified this wrong, you then think you can't do dividing radicals. Does everybody understand the difference? Like, making a mistake in this step isn't you not being able to do this. It's you forgetting that first bit of simplifying. Does everybody understand that? It's a serious problem that I face when I'm teaching you guys stuff. You think you can't do new math because you made a little mistake on the old math. That's not the case. Everybody's with me, yeah? All right, are we all good? We all good? All right. So, what's happening here? That would be exactly the same as 9x minus 3y over 4z. Right? You can't do anything with that, can you? Can we do anything with that? No. So we can't do anything with this except possibly simplify that root 20, right? Which would be what times what? 4 times 5. What's the square root of 4? So it'll be 18 root 5 minus 3 root 10 over 3 root 2. Now I have a choice here. And what I'm about to show you is something that almost all of you at one point or another this year are going to forget what I'm about to show you. So I'm going to show it in a crazy color that I never use. Almost. Orange. This is the same as 18 root 5 over 3 root 2 minus 3 root 10 over 3 root 2. The 3 root 2 is the denominator for both of those. Now, this would become 6 root 5 over root 2, correct? And this would become root 5. Everybody cool? What in orange isn't allowed there? Just the root 2, and we would deal with it. Everybody cool? I'm going to deal with it up here because I don't want to do this split up thing. Because I know I've got to deal with that root 2, which means I've got to multiply this by root 2, yes? And then if I want to put them together, they're going to need the common denominator anyway, aren't they? But I already have a common denominator here, so this is the one I want to work with. Everybody cool? But I need you to be aware of this for future. So let's deal with this. What here don't we like? Just the root 2. So that's what I got to get rid of. Now, you all know how to multiply this. It's just distribution. What is the first term? Which I will highlight in green. What is that going to give me when I multiply that by root 2? 18 root 10. Bea, you are on fire. Marcos, don't get too comfy. Oh, he leans back, Bea. He's challenging you. What is this one? Oh, listen, a guy in the back corner wants to keep his chair now. What is it, Marcos? Negative 3 root 20 over what? 6. Now what? There's something there we don't like. Right now you're sitting at a 3. You all want the 4. What can I do with what's written in red there? Before that, Marcos. Simplify what, Adara? The root 20. Because that's 4 times 5, right? So what's coming out? 2. So I've got 18 root 10 minus 6 root 5 over 6. Now you're at 3.5. Who wants the 4? All of you. What do? 6, 6, 6. They all work together, don't they? What's what? 6, 6, 6 all works together, yes? So what's 18 divided by 6? 3 root 10. 6 divided by 6? 1 minus root 5. And do we have a denominator anymore? No. That gets you the 4 out of 4. Now please notice what is the only new thing. Two times 2. Root 2 times root 2 is 2. 3 times 2 is 6. What is the only new thing that you did today? That step right there. And was that really new? Once you learned you're not allowed to have a root in the denominator, you already knew how to get rid of everything in math that you need to get rid of. You do the opposite of what you see. And you already know that the opposite of square root is squaring. So nothing new today except that step. Right? What's happening here? Can I do anything? So what am I multiplying by? Root 5 over root 5. So it is root what? 60 over 5. Can I simplify root 60? When did I go fast? Done. Now remember, ladies and gentlemen, we only have to worry about the stuff we don't like. Now, some of you will insist that, Mr. Myers, it's just easier if I multiply by whatever is on the bottom. Will that still work? Yeah, but just like when you choose a common denominator that is too big, it makes simplifying it a pain at the end. Okay? But it's totally up to you. I want to multiply that by root 6 over root 6, because I can't get rid of that. So that gets me 2 root 6 over what? 5 root 36. And root 36 is really what? 6. What's 5 times 6? 30. So I have 2 root 6 over 30. Would Mrs. Bad Crumble let you keep that fraction? Would she allow you to have a 2 in the numerator and a 30 in the denominator? No, because what is that? That is 1 over 15. So it is root 6 over 15. Root 6, not 16, you idiot.
I was wondering why there's 5 on the bottom. Is it like in red there? I thought you did 5 root times 5 root.
Root 5 times root 5 is 5.
It's not 25?
It's the root of 25, which is 5. Anything happen in K? All we got to remember in K is there's a negative. Yes, Bea. Well, what is, it's root 6 times root 6 is root 36. The square root of 36 is 6. So it's 5 times 6. Okay, your job is to finish page 45. It is only 4 questions. And you know how to do, I lie, it is 6 questions. And you know how to do all of them. You have 6 questions of homework. Try to get it done.